This is week 2 assignment. First assignment, given the isometric pictorials, sketch the 3 orthographic views. You will be given, as you see on the left-hand side here, an isometric pictorial. This is problem number 39 in the book on page 293. No, probably 294 or 5. It's about in the middle of the set of pages. So make sure you fill in your name, your section number. You're either 01 or 02, not section A, B, but 01. 10 o'clock class, the 10:15 class is section 01. The 1:20 class is section 02. So maybe fill that out. For this online semester, it's a little bit crazy trying to figure out how things are going to be due. So you're going to hand this in by either scanning or taking a picture of it. Make sure the picture is clear. And you're going to make a PDF and send me a compiled PDF of all 8 of the problems in one PDF, please. And then I can red mark them and send them back to you. Assignment, this would be assignment 2, or week 2, assignment 1. The page number, I'm not sure. It's 39 though. I think it's page 290 something, 294 maybe. 4 or 5, something like that. You have room for 2 problems per page. We'll do 1 problem up here and 1 near the bottom of the page, okay, this way. So there's the header. Let me move this a little bit. We're going to need a little bit more room to work. Okay, there we go. Now, as you see in the book, they show you an isometric, a wireframe isometric pictorial, and I already have the letters. I named the planes by putting letters A, B, C, D, E, F. That's so as I call them out, you know where they are. But that's also a good way to do this. Okay, first thing we're going to do is you're going to set this drawing up. They always show you in the book the best orientation of the part. So most of the features are seen in the 3 views that are visible. The front, the right side, and the top view are visible. So that's how we want to lay it out on the sheet. 1 square in the book is like, we'll call it 1 centimeter. These squares are approximately a centimeter. We're going to double the size. Okay, so for every square in the book, you're going to put 2 squares on this page so that we draw our part as large as possible. So let's do the top. Looking at the top of the part is got a depth, a width, and a height. Our width is across the front. Height is, of course, the height, and the depth is across from front to back. The part is 6 wide, 4 high, and 4 deep. Doubling that, it is 12 wide. 1, 2, 3, 4, 5, 6, 9, and 12 wide. It is 8 deep, 4, 5, 6, 7, 8, and it is 12 again wide. So I draw it very lightly, okay? Not all these lines are going to become object lines, but so this is a construction line. We're then going to go 3, 4, 5, 6, 7, 8. This is what you'd use your thin drafting pencil for. Make a thin line, but very light. I'm probably making it darker than it should be, but I want to make sure it shows up on the camera for you. And then let's do the width, the right side. 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. And make the box. So count them. Make sure you got them to the correct proportions, the right size. This is the right side. This is the front. And of course the top is up here. Now we put reference lines between the parts. If you've done this in high school, they probably always made all your parts exactly the same, each view the same distance apart. So this is a reference line between the frontal plane, between what's called the frontal plane, or the front or back plane, and the profile plane, P for profile. This reference line, REF, can you see that? Yeah, good enough, is between the frontal plane and the top or horizontal plane. Now, where these two reference lines come together, that's where the miter line starts. And it's at 45 degrees, like that. Always 45 degrees. 45 degrees, exclamation point. Has to be at 45 degrees or projection, the tool of projection won't work. So this is the front of the right side of the part. Okay, this is the part. This is the front of it. Notice if you project up and hit the miter line and turn 90 degrees, you hit the front of the top view. That's how you know they're going right. If the miter line is not at 45, you can't use this tool to project into the other view. So the back of the object should project to the back. Front of the object should project to the front. So here's the front view. This is what we call the width. Here's the front view here. So this is the width, left to right. This is the depth, okay, in the right side view, left to or front to back. And the height, of course, is the height of the object. So when I say width, I'm talking about left to right in the front view. If I say depth, I'm talking about left to right in the right side view. And of course, height is height. So the front has a width and a width and a height. The right side view or the side views have a height and a depth, and the top view has a width and a depth. Okay, you can draw the whole view, or you can draw just one contour in a view and draw it in all three views, any way you want to do it. I usually start with the normal planes, the horizontal and vertical planes, because they're usually, easier to visualize. So, for instance, in the front view, plane A is a horizontal or vertical plane that is, according to the book, 2 squares wide, so we double it to 4, and we go up 1 square, double it to 2, and then we go over to the corner. Try and keep your line straight. When you get the contour drawn, now when I say contour, contour means shape. So there is the shape of A. Okay? Every plane will either be a contour or an edge view. Contour, you see the shape, whether it's foreshortened or not. And the edge view is, of course, just a line. So there's A. A in the top view is a edge view. So A in the top view. Solving for edge views doesn't really give you a whole lot, okay? But I will label it with a letter inside the contour. If it's an edge view, I'll point a little arrow to it and label it pointing to the line. Continuing on, E, let's do E. E is 4 units wide from the side of A here. And it is 4 high, or 2 high, and we double it. So we're doubling it to make it bigger. There's E. 2 units wide, 2 units tall, so 4 by 4. And F. Now, the edge of F that attaches to E, we could call point 1 and point 2. Point 1 and point 2. F is somewhere here. Okay? The back right side of F, point 3, here's the right side, and there's the back. So that would be point 3. Okay, here's the back. That's point 3. Here's point 1. It's in the front, so this is point 1. Point 2 is projected over here somewhere, and point 2 is also in the back. Okay, so that's 2. So 1, 2, 3. If you number the points and figure out where they are in any 2 views, you can find it in the 3rd view, and you can number it. And there's F. It's a triangle there. It is at 1, 2, 3. It is a triangle here. Now look closely at the, well, we'll get to that later. So we got A, E, and F there. The more lines you put in, the easier it is to visualize what's going on. B is an oblique plane here. Let's see, D is this line in edge view. And the top is C. A, B, C, D, E, F. I found them all. Okay? So the front view is done. Top view. C. Go a little faster. 8 by 4. 1, 2, 3, 4, and across like that. There's plane C. Okay? Plane E, we can project the left and the right side of E up here. So E is this rectangle. It is 4 wide, just like in the front, 4, and 8 deep. That's just the horizontal depth. It's actually an inclined plane. There's E. Okay, so here's E. F, we numbered it 1, 2, 3. 1 is in the front on this projection line. 2 is in the back. And 3 is back there. We already found it. So 1, 2, and 3 goes back to 1. That's F. What are we missing? B is here. This line is D. Let's go to the right side. So we have A, B, C, D, E, F. We found everything. Go to this side. C is a horizontal plane from the front all the way to the back on the top. So there's C. D goes from 1, 2, 3, 4. This point down to this point. 1 unit high, or double it 2. So this shape, 5 sides, is D, and that leaves us with B, and A is the front face. A, B, C, D, E, F. So we found them all. Okay? Now if this thing had a hole in it, let's put a hole right here in the top. We would have a hidden, I'm going to put a hole just so we can use all the line types. So we had a hole right here. That's not very round. A little better. If we project it, when we show a hole, it's going to say it goes all the way through the part. So then we'd put in hidden lines for both left and right side of the hole. From the very top to the very bottom. Hidden lines, we usually break them across the object line. Sometimes it's hard to do it. And the center line shows where the center of the part is. So your object line should be nice and dark. I should have had a sharper pencil for the hidden and center lines. They should be a little bit thinner. We can project the center of the hole in the top view over to the miter line and down, and that's where the center line, let's move that D over. The center line, remember, is a little bit longer than the actual hole, the actual surface. Project the front of the hole over and down. Let's make that E here. And the back of the hole is projected across and down. I need a sharper pencil here. I need to sharpen my pencils. So there's the hole. That's how you'd show a hidden line, or holes in a center line. So what do lines mean things, okay? What do they convey? They convey information. What information do they convey? Well, a hidden line conveys that this feature is in the background. So it's behind F, the plane F. It's behind D, okay? And it is. It's behind E and F. It's to the left side. It starts and stops at certain planes, the top plane and the bottom plane. Okay, so that's what it tells us. Object lines tell you something too. Whenever you have a line that object or a visible line intersecting another visible line, at that point something is happening. Okay, lines mean things. So what is happening right there? Well, what is happening right there on plane A is that the perimeter of A is changing shape right there. Okay, it's changing. It's going from a vertical plane to inclined on a vertical plane. That's what that means. Right here, this line intersecting that line means the same thing. C is changing shape. Okay, but it also says that this plane D that we can only see the edge view of, D is also changing shape. It's at this point on D, if we project over and down, that it is changing here. The perimeter of D is changing shape here. At this point, D is changing shape. It's changing direction if you were following the perimeter. Okay, so that's a clue as to what D is happening to D. Say we didn't have the right side view and we didn't have an isometric view. How do you know what shape D is? You have two edge views of it, and if nobody gives you this or gives you an isometric and nobody gives you the right side view, you have to come up with in your mind what the shape of D is. Well, you can measure the edges, but you also have to, this tells you that the shape of D is changing. Okay, if you were tracing the contour of D, it changes there. It moves in another direction in here. Okay, and each view, wherever something is touching it, it's changing direction. Right here, it's changing direction here. So there are clues to what's going on, and sometimes you have to look carefully at the lines. What do the lines mean? Okay, what does this line mean right here? We know that we're pointing it to it, and we're saying that is plane C. Okay, what does that mean? A line means either if a line represents an edge of two planes, or it represents a plane and edge view. And you have to figure out in every view, when you see a line, does that line represent an edge of a plane, that I'm looking down the plane, it's an edge view? Or am I looking at the edge of two planes, like the roof of a house, the edge of the roof of a house, the top of the house, okay? So, lines mean things, and one line might mean something a little different than another line. So, you have to, these are the clues that you get. So this is what you need to do. That's one example. I'll do another example, but that's for another video. The requirements for this homework assignment are you have to I want you to sketch lightly with construction lines and set the problem up. Make sure you don't have it, draw the top view maybe first or the front view, but leave room for the top view. You have to fit 2 of these problems per page, okay? So first, construction line, very lightly with the construction line of the overall size of each view, because some of those lines will turn into object lines, some will not. Okay, like this line did not turn into an object line, so we don't want that line dark, or it'll mess with your mind. When you're trying to visualize a three-dimensional object with these pictures, with these orthographic views, a dark line is easy to remember that that's an edge that exists. A light line is an edge that does not exist. If you draw everything dark, it's hard for your brain to differentiate sometimes when you're trying to think it through. So, make construction line boxes first. If you make them too dark, erase them. Okay? If they get in your way, if they're messing with your visualization skill, then get rid of them. But if you draw them lightly, you don't have to. You need to label each view, because labeling the views tells me that you know what the view name is called. If you don't label it, I assume you don't know what it's called. So label the views. Put in the reference lines in the miter line. It is a tool that you may use in solving a problem. You may not use it, but you're showing me that you know how it goes in there correctly. Now, where does it exactly go? If you did this in high school, a lot of times they put the reference line halfway between the two views. Notice over here I have the distance farther away. The front view from the right side view, they're farther away. You might have been asking, why do you do that? Well, here is in your PowerPoint notes on methods to aid visualization slide. It says one of your methods to aid visualization is your related views rule. Related views rule number 1 states the following. The distance from the reference line, put an arrow there, to the front of the top view. That distance, let's call it D1. Okay? Has to be the same distance as from the other reference line, there's arrowhead, to the front of the other adjacent view. This distance is D2. The related views rule states that D1, distance 1, equals D2, always. Okay? That shows you where the reference lines are and then where they connect, that's where the miter line goes off at 45 degrees. This can be off in 45 degrees in any quadrant, so you could draw a left view or a bottom view and still use projection. That's related views rule number 1. Okay, we have another one later in the semester. The distance from the, say, the top of the object to the reference line, let's call that distance A, and the distance from the right side of the object to the other reference line, let's call that B distance. A can equal B or A cannot equal B, we don't care. Okay? It's the distance from the reference line to the adjacent object. That distance has to be equal. Okay? So I could have my right side view way over here. I could have a reference line here, and my drawing would be 1 unit away from there. Okay? And my reference line would be moving over too. You say, well, why is that important? Well, let's say on the test, here's your sheet of paper, and I tell you, here is your front view, F for front, here is your right side view. Okay? Do you only have it in there? Okay, there we go. There's your right side view. Your top view would go above here. Okay? Here's the problem. If you put the reference line halfway between, then this distance is what you need between this reference line. If you make the same distance across, if this distance is the same as this distance, then your reference line is way up here, and you don't have room to fit your front view or your top view. Okay? Because I made these in the test too far apart. But if you put your reference line way over here and way down low, then when you project up and over, and here's the back of it, up and over, your top view ends up fitting on your piece of paper. Okay? So anyway, that's the related views rule and where you put your reference and miter line. Okay?